All right, good morning, everyone. Today we're going to be going over OOP, doing a complete review from start to finish over what OOP is, how does it work, and how do we create this school interface. Now, this assignment was specifically chosen for the review because it has a lot of common ground with our assessment. So it's going to give us the best prep, the best bang for our buck before starting our assessment this weekend. So again, this assignment's um, pretty straightforward. What it wants us to do is it wants us to build a school interface for Richmond High, where we'll be managing students, and we can load the staff that is also being created here. It gives us step-by-steps on how to complete this assignment. And I already went ahead and took a look at everything that's being handed to me. I see that school is a class with no class level attributes. All three of these classes don't have any class level attributes, so that's good to know. They have instances where information can get loaded and then handed over to the class. So with that said, let's go ahead and start this assignment. I'm actually gonna treat our drawing as a separate screen. It may cause us to switch back and forth between screens, but I do want to be able to read this README as information comes in. So I'm going to come over here. I can see that the two files that I have available to me are school and runner. I have a data file that has CSV information. So we'll also be interacting with those files here shortly. So starting off, we want to actually open up the school and create our school. So here it tells me, hey, this is how you're going to be able to create a school. In the runner, you should have the following information. Okay, so I can see that the runner already is open, and the only attribute that's being passed into it is of school, or excuse me, of name. So I can define my initial method. My init method should take in self and name. I should say self.name is equal to name. And just as a quick refresher over getters and setters, again, since I'm going to create a property, the property should have a decorator named name, where it will take in self and return self._name. Then I want to create a setter there. Notice how self._name currently is white. It's not able to recognize that this is an attribute because it's nowhere inside of my init method. So I need a way to be able to create it. So I'm going to call the getter.setter, place that inside of my decorator. Then I'm just going to simply define name, which is self, new name. I expect a string. This shouldn't return anything, so I could just say it doesn't return anything. Whereas up above, we were in fact returning string. And all I need to do here is, since there are no conditions, I can say self._name is equal to new name. All right, so there's my school class being able to be executed. I can see the import statements coming in from school. So I can just execute the runner to ensure that everything works great. And I see Richmond High being printed onto my terminal. Now, does anyone have any questions over the school class? Let's hear it, Alex.
I'm sorry, maybe I didn't catch it, but what was it in the instructions that said what prompted you to make a getter and setter?
The instructions didn't say anything. Right now I'm specifically just making a getter and setter so that we can see it. I want to make getters and setters as much as possible when we go through this review so that when the assessment comes along, we've seen this in rinse and repeat portion as many times as possible. Does that answer your question, Alex?
Yeah, and I'm glad because I need the review on that.
All right. All right. Anything else? Let's hear it, Elias.
Yeah, so I've noticed that some students see confusion in the init, how you have self.name equals name and sometimes it's underscore name. Can you elaborate a little more on why it matters or doesn't matter what it's called there?
Yeah, absolutely. Let's go ahead and let's change a couple of things here. Let's do argument name. This is going to be our set name. And we could just call this our get name. And let me change it down here as well. Okay, so hopefully this helps a little bit as far as visualizing it. You'll notice that now my print statement fails, right? I have to change that to get name in order for that to be able to work. Now, let's see what's happening here. I call my initializer method. I pass in a name. So I could say argument name is equal to Richmond High. Richmond High gets fed into my init method. And argument name gets passed in to the setter. Right, so this is set.name. Now set.name, it specs a new name string, which is currently the argument that I'm being passed in. And that new name is getting set to self.name. Now it's nowhere in my initializer, but this line of code here in line 12, what it actually does is it creates a self dot underscore name. Finally, my get name calls my get name property that just returns self dot underscore name, right? This underscore here is not actually doing anything. It's not reinforcing any sort of Pythonic code. If I still wanted to access it through the underscore, I could. This is purely syntactical that we tell other developers, hey, you shouldn't be interacting with this property because it's followed by an underscore. And because it's followed by because it's precursed by an underscore, you should be interacting with it through a getter, which we're doing here, or a setter, which we are doing here. I hope that helped clarify things. Does anyone have any questions over getters and setters? Okay, it doesn't seem like we have any questions. So let's go ahead and clean this up a little bit, starting off with our getter. I'm going to take off that get underscore. Now I'm naming it the same exact property, just without an underscore, right? Because the underscore makes it a unique value, and that's what falls right here. Let me make sure that this can still be executed. Great, everything's still working there. Now, I don't want to call this set name because that's not the right convention. I actually want to call it just name. So now when I execute everything still works. And finally, I'm just going to take off this argument name portion. All right. Any other questions regarding the school class? Go ahead, AJ.
So I'm sure there's a reason, but how come we can't just initially format it like that instead of have to go back and take it off? Like, you went back and you cleaned it up a little bit. Why couldn't we just start with just the self name, self dot name into the property and name setter?
We did start like that. I actually went back and refactored it and added the get and set name, and now I'm just taking it back off. So the initial iteration had the underscore, this just this regular naming convention. I went back to add some extra syntax just to try to clarify getters and setters.
Okay, thank you very much.
Of course. All right. Okay, so let's continue on with our README and see what's next here. Okay, so Richmond High, that's able to work. Oh, look at that. It even gives me what the class is supposed to look like. Perfect. So let me go ahead and change this here. The next thing that we want to do is we want to call self.staff, which I know is going to be a list. Save that to an empty list. And self.students, which again will be a list, and save that to an empty list. All right. So this was taken care of. Now the next thing we have are going to be students and staff. And they're both pretty much the same class. I'm going to go through the process of actually creating both of these, but I don't want to create them inside of the same file. I feel like it would clutter things quite a bit. So I'm actually going to make a new file. I'm going to say touch, and then I'll just do members. Why not? Or actually, do school personnel.py. Let's code school personnel. And let's start creating both of these. Instead of looking at this here, I'm gonna utilize my TL draw to create both of those. So I'm gonna do my class of student, which I'm going to pass. I'm going to do my class of staff, which I'm also going to pass. And now let's take a look here. It tells me that it's supposed to load the CSV data. So I'm going to open that up. Let's do code, data, and I want to look at student. All right, so from this data, I can see that the attributes that are being passed in will be name, age, role, school ID, and password. So I can come in here, say def init, takes itself, and then the following arguments. Now I could add some typecasting here if I really wanted to. Note that typecasting is not going to be part of the assessment, so don't worry if you don't truly understand how this typecasting works. And then finally, password. All right. So there's my information. I'm able to bring in my student. Now let me actually set some attributes here. I can do self.name is equal to name. I can say self.age is equal to age. I can do self.role is equal to role. Finally, self.school ID is equal to school ID. Now let's take a look at what staff looks like. Okay, so staff seems to be taking in almost the same exact number of attributes. There is a little bit of a name change there. That's very important. So I'm going to do my def init, take in self as my first argument, and then bring in everything. So again, we have a string, an integer, a string, and password seems to be part of the same information as up above. It looks like the only difference is school ID and employee ID. Everything else remains the same, at least from what I can tell. I'll do a quick little change here to check. We can do self.name is equal to name. Self.age is equal to age. Self.employee ID, or excuse me, role is equal to role. self dot employee ID is equal to employee ID. And then self dot password is equal to password. All right, awesome. So there's both of my classes. I'll create getters and setters here shortly, but I'm seeing a lot of commonality between the two. So because I'm seeing a lot of commonality between the two, I'm going to utilize inheritance to fix this issue. I'll say class, not clues, excuse me. Let's say school personnel. Go ahead, Tom.
Yes, sir. Wouldn't student also need self.password?
Student password, it does. Yes, I missed that. The self password. Thank you. All right, awesome. So now school personnel should have an init method that takes in self and the following arguments. Everything with the exception of employee ID, because that's the only one that's unique to each class. Nope, that ain't it. Okay, so again, I can say self.name is equal to name. Self.age is equal to age. Self.role is equal to role. And self.password is equal to password. Okay, great. So there's all my information. I have my school personnel, my student, and my staff. Does anyone have any questions over how I declared over these class declarations? Let's hear it, Arnold.
Yeah, so since you already declared all your init in your parent class, can you remove the name, age, role in the subclasses and you just put the class student in the parentheses, the class parent? Can you do that?
I can, yes, and I will apply inheritance. I just haven't gotten there yet, but yes, you're in the right track. That would be the
Okay.
next steps. All right, AJ.
Okay. So I haven't done any that requires multiple files yet, so I haven't got there. So everything we're doing in the personnel, eventually we're going to import it or inheritance it into the master file of the school. Or am I not understanding that correctly? Or are they going
You
to
are.
stay separate?
No,
Okay.
you are. Everything will essentially be imported into the school.py.
Okay.
All right. Okay, let's see it. And let's start applying some inheritance. Oh, go ahead, Alex.
Sorry, how did you link the CSV to your files?
I haven't done that yet.
Okay, because I saw that you ran it in the terminal and it popped up, I believe.
Yes. So
Oh,
this
but it wasn't going through the classes files.
that's right. So I'm not
Okay.
executing any code with them just yet. I was just looking at them.
Okay, got it.
All right. So now I'm gonna go ahead and inherit the school personnel class. Now, because the school personnel class already has name, age, role, etc., I'm not gonna need any of those. The only thing that I need is my school ID. And because I'm overriding the init method, I need to utilize super to pass in all these attributes into the school personnel. So I'll say super dot init. And what I'm going to pass in will be name, the age, the role, and the password. I'll do the same exact thing down below to the school personnel. Everything can go with the exception of the employee ID. So I can say super dot init name, age, role, password. And there you go. I have both of my classes refactored with little to no code being repeated. Okay, fantastic. Does anyone have any questions regarding inheritance? Okay, it doesn't seem like we have any questions, so let's go ahead and keep going here. So we have my student staff, we have our students, we have our staff. So in release 1, refactor with the dictionary for corgs. What does that mean? Let's see. Okay, so it wants me to be able to create a student with corgs. That's okay. We already know how to do that. And we're probably gonna see it here shortly. Okay, so it wants me to restructure information to have a person, staff, student, and school inside of a directory named classes. And then it wants me to work on a load students. That's the part where we're gonna actually interact with a CSV file. All right, let's go ahead and do this portion. I'm gonna open up my directory or just my file scope here on the right-hand side. Currently, we're within this OP school dash interface. You can see I have school personnel, school, data, etc. Well, I'm going to make a directory named classes. And inside of this directory, I'm going to place school. School. Oh. All right, so there you go. I can see classes now has school. Inside of classes, I'm going to create a file named student.py. And I'm also going to create a file named staff.py. Finally, I'll need a persons.py. Okay, so there's all three. It looks like it wants me to call it person, my inherited class. So I'm just going to go ahead and change that really quick to be person. Everything else still remains the same. And now it's just a matter of managing information. Here I have my runner. I can see that my runner now has an issue because it's trying to import school and school is not within the scope that I'm trying to grab it. I need to actually go into the classes directory and grab the school file. So I need to fix that path. Gonna go ahead and open up person. This is where my person class should live. From there, I can go over to my staff. Grab my staff class. You can see that there's an error there. Well, I can say from the directory classes, person, import person. And now you can see all of my staff is loaded. And then finally, I have my student, which I could just rename this file, but I've already created a student file. So it'll be easier to just cut it and paste it. And again, from classes.person, import person. Okay, so everything has been created the way I want it to be. The folder structure that they required. So here's classes, I have person, I have school, I have staff, and student. All right. Let me make sure my runner can still execute, and I'm actually going to remove that file of school personnel. I'm going to say Python runner.py. So my runner's still working. It's able to read all the data, but my data isn't actually being utilized on my runner just yet. let's make sure that that can actually happen. Okay, coming in from school, I'm going to come over to the school class. And in the school class, I'm going to say from classes dot staff. I'm going to import staff. And from classes dot student, I will import student. At the very bottom of this file, I'm just going to add a couple of print statements here. I want to make sure that those classes exist and that it's able to read them properly. So I'm going to run student and staff. Now, when I execute my runner, I can see that the students and staff are being printed. So everything's working according to plan. All right. Before I keep pushing forward, we did quite a bit of file restructuring and we added a couple of import statements, which we haven't really talked about other than our intro to Python class where we covered a little bit of file structure and import statements. So does anyone have any questions over how we refactored our code, why specific things are following inside of what location, and why our import statements look the way they look? Go ahead, Rick.
Yeah, I'm sorry. It's not really a question, but yeah, this is making a lot of sense now. It reminds me of the .NET framework. Also, I don't think it's brought up in the class, but separation of concerns, big thing in programming. If something goes wrong in your code, you know exactly where to look because you've separated your classes into separate files into separate folders, so you know exactly where to look.
Nice. Awesome. Good observations, Rick. Appreciate it. Go ahead, Tom.
Yes, sir. Just for refresher purposes, if they weren't located within the same directory, is that when we'd need to do the import OS and give a relative or absolute file path?
So what you're talking about is going to be how to declare the file path. And that depends on the specific function that you're trying to work on. If you're working on something like an actual code function that requires Python or that requires a path, then you would utilize OS. Import statements from up above, you'll usually do it in this order, where you'll specify information through a dot notation, not an actual path.
So
And
that
we'll,
would work even if they're not in like the same directory?
if they're not inside of the same directory, let me see. Let me add something else. Here, fun.py. Oh, can't do that. Okay, change directory into fun, and then here I'm just gonna do touch foo.py. I'm going to so currently they're not in the same directory, right? We have fun, and then we have our classes. Well, if I go to my school, I can say from fun.foo, I want to import say foo. And then I can call the function. And then we get that foo statement there. All right, so the import still works. I just have to specify where it's coming from. And then the reason why this is working the way it does, because if I try to execute the school file, this here would throw an error, right? The reason this works is because all the code is being executed at the runner level. And we can see it here on the right-hand side. The runner is within the same scope as data, classes, and in this case, foo. So since all the code is being executed from the runner, all of the neighboring directories and files can be grabbed and executed at the runner level. Does that answer your question, Tom?
Yes, thanks.
All right. Go ahead, Ryan.
Hey, sorry, real quick, would you mind just like going through each of the files in class, like just briefly, I don't need an explanation, just to like see what is in each, and then I guess so I can like, visualize how that feeds into runner.
Yeah,
Does that make sense?
absolutely.
Okay, thank you.
Let me go ahead and bring up my TL draw here. Okay, so currently we have these files. We have a person class. And I apologize, but I don't want to run out of time, so I'm going to leave this person class empty, but just know that we're inheriting from it. All right, so we have this person class, we have a staff class, and we have a school class. And then finally, we have a runner. Now, in our runner, our very first line of code is, hey, from classes.school, import school. Well, what does that mean in regards to the runner file? We know that the runner file eventually has a print statement that prints school dot name. Well, when the very first line of code says to import school, what's actually happening to the runner, and let me actually make this a little bigger, is we're saying, hey, take this entire school file and I want you to execute this school file first before running any of the code inside of the runner. And that's happening because of my import statement. So I can highlight this in red. Go ahead and put that red as well. Okay, let's make sure that that's actually true. Right? I can come over to my school and say print execute school.py. Now, when I go into Python runner.py, you can see that the first print statement is actually execute school.py. And then Richmond High. All right. Well, in the very first lines of school, we have staff and student. Well, what does that mean in regards to the class file? Well, that means that in regards to the class file, the very first thing that gets executed, and I think it's students, let me make sure. Nope, it's staff. Right, the very first thing that gets executed is our staff. So let me make this green. And we can ensure that that's true by going over to staff and adding a print statement saying execute staff. Well, now when I run the runner, we can see execute staff, then execute school.py, and then Richmond High. All right, so things are starting to fall into place there. The school runs the staff first. And then we have our student. Or student would be next in the class. Let me make this something ridiculous. There you go, purple. And I can come back here and go over to the student and add a print statement saying execute student. So there we have staff, student, school.py, and then Richmond High. Right, so staff, student, school.py, and then Richmond High. Okay. And then finally, in our last level of nesting, we have the person class. And we can see the person class being executed by adding print execute person. Now, when I run the runner, person is the first file to get executed. Staff then gets rendered. Notice how person, even though it's imported into student again, it doesn't get ran a second time. Right? It just uses the already established person class. Finally, it goes into the school, and then we see the print statement from the runner. So from a runner's perspective, once I'm actually executing code, it starts from the very bottom, which in this case, it's person, the least nested. Then it flows to staff. Then it flows to student. Finally, school. And then the runner. Did that address your question, Ryan?
It did, yeah. Thank you very much.
Of course. Go ahead, Alex.
So I noticed that I guess this approach to the whole file management is like waterfall based, so to speak. And is that best practice compared to maybe from school, from staff, from student, from person, all in runner? Where you just chunk all of them together in runner instead of connecting person to staff, staff to school, school to runner.
So that kind of goes into, that's a system design question. And this is the way that I would ask it. And Rick kind of hit on it a little bit before. So we have the single responsibility principle, which we talked about earlier. Right? Just like every function is meant to do one action, every class is supposed to represent one object, and every file should isolate the behavior of one project. All right. Currently, I have a staff project, a student project, I have a school project, and then finally I have the runner, which is executing all three projects at once. Now, that's the textbook answer, right? Follow the single responsibility principle. The way that it matters to me as a developer is always think of when you're structuring your code or your file structures, think about it in a way of if something breaks and I have to figure out what's wrong, is it going to be easier for me to figure out what's wrong if I import everything into the runner or if I have everything broken up into independent files? All right. If you import everything into the runner, you're possibly looking at hundreds of lines of code where you're trying to debug everything to make sure that it works properly. Whereas if you follow this structure where everything gets broken up into independent files and then only reference to where it's necessary, right? Because the runner doesn't need to know about person. It doesn't care about person. It only cares about the school. That's what it's there for, to execute my school. Staff and students, they need the existence of person. And school needs the existence of students and staff. All right. So I'm only giving the data necessary at each level in order to keep the program running. Does that answer your question, Alex?
It does. And just for sanity's sake, can I see the runner.py file real quick? Okay, cool. Thank you.
Of course. Arnold?
Oh no, I just wanted to see the runner that file too.
All right. Any other questions? Okay, good to go. Now, this part's going to be a little tricky because now we're going to be actually dealing with the student information, where we're going to be importing everything from a CSV file. So I'm going to start off with students. We know that this is going to be a class method. It's meant to return a list. This is going to be named load students. We could make it dynamic to take in a path, but we'll get to that later on. The only argument it's going to take in will be CLS, and it will return a list. All right, I'm going to actually take off this print execute information. I think there's one more in staff. There you go. Okay. Now this needs to open a CSV file. So I'm going to say with open. I need to pass in a file. I'm going to establish a new line here. I'm going to call it as student data. And because I want to do this with CSV, I can go ahead and import CSV. It's already installed inside of Python. There's no additional pip install or anything like that. We could just reference it. So now I can say reader is equal to CSV dot dict reader and open up the student data. Finally, I can iterate through it. So I'll say for row in reader. I'm just going to print row. Now, a couple of things that I have to clean up here, or at least one thing that I have to clean up here, will be the file path. As we mentioned, the only file that's being executed is the runner. So the path must come from the runner. So I'm going to take a look here. If I'm looking at it from the runner's perspective, I can say within this directory, there is a data directory that will take me over to student.csv. Right, the runner. So from this directory, that's the period. Yep. From this directory, there is a directory named data. And inside of data, I want to grab the student CSV file. And this here is actually an example where you can utilize the OS method that you mentioned, Tom. So just to reference your question earlier, you could utilize the OS method here. For simplicity's sake, I'm going to keep it with just a relative path. All right. Now let's see what happens when I execute this code. I know that I'm going to need it within the school, because instead of just having this staff, I want this to actually be the school. So I'm going to call students dot load students. And I can execute my runner. I can see that there's a little bit of issues there. Let's see what's going on. So it's telling me print Richmond High was fine. Student load students with open, so no such file or directory. Okay, so it's having a little bit of issues finding this. So let me make sure that matches our naming convention. Okay, so the issue is that I have an S. Right, whereas in the README, that student CSV file didn't have an S. So I need to specify that that's there. So students. And now my runner works great. For every single row of data inside of that CSV file, I am creating a dictionary. All right. Now there's a little bit of typecasting that I need to do. For example, we know that our school ID should be an integer. And I'm seeing that some of them are followed by zeros. So maybe that's not going to be possible. This might have to get turned back into a string. And I could do that in persons as well. Oh, that one's unique, so I don't need to do that. Perfect. All right, so school ID should be a string now instead of an integer, specifically because of that 0. So the only thing that needs to get typecasted to be an integer will be the age. Okay, so I can change this to say row at key of age is equal to integer. Row at key of age. I'm just turning this key into an integer. Now I can print row, and I'll see a difference there. You can see that now it's no longer a string. It is actually an integer type. And everything's able to come in great. Well, I know that I want to return a list. So I'm going to name this students from CSV. And for every single row, I'm going to create a new student. So new stud is equal to CLS, which is a reference to the class itself, and the structure, that dictionary. Finally, I can say students from CSV dot append and pass in the new student. When we're done looping, we can then return the students from CSV. All right, so we establish a list. We open the CSV file, turn every single row into a dictionary. From there, we iterate through those rows. We typecast the key of, or excuse me, the value of age to an integer from a string. We create a new student instance. Because this is a class method, I can utilize CLS to reference the class itself. Append the new student to the list, and then return it. So here's my CSV file, or excuse me, here's my school.py. Self.students would then receive a list of students. So I can even change this and typecast it to say, hey, it's going to be holding a list of students. Well, let me go ahead and add a new print statement here where I want to see the students. I'll execute my code. And what I get is a list of class instances, all of which are student objects. All right. Now this function is kind of a monster. So I'm going to go ahead and pause here and open up for questions. Does anyone have any questions regarding how we loaded our students? Let's hear it, Tom.
So yeah, a couple. First off, why would it necessarily be a class method if we don't have any like class attributes that we're messing with?
Got it. So a way to think about this method is creating an instance of a student, right? So do you want a student instance to be able to create other students? So for example, if we have Jimmy, would Jimmy be able to create other students inside of a class? No, right? So because we don't want them to have those permissions, we put it at a higher level, turning it into a class method. All right, I'm seeing the head nods.
Yeah, and then there's the second part of that. And for row in reader, what is that referencing per se? Like which part of that dictionary is it reading? Is it reading like each student entry? Or is it describing each key value pair for a student?
Got it. So this for row in reader is referencing every row inside of the CSV data, meaning Lisa 25 student, the ID and then password, that is one row as a dictionary. All right, when it iterates through the next one, this will be our next dictionary or represented as row. So I could change, let me change the naming convention here. Let's say data row, right? Because it's calling a row of data as a dictionary. Does that answer your question, Tom?
Yes,
Oh.
thanks.
Perfect. Any other questions? Let's hear it, Alex.
How does your class method know that name, age, role, school ID, and password in your CSV file isn't a student itself, or creating an instance of a student?
I think I'm confused by your question. Could you ask it again?
So that line 1 in the CSV file, how does it know that that is not a student itself, whose name is name, age is age?
Got it. That's happening from Dict Reader. This Dict Reader tool takes it so that the very first portion is considered the keys, right? It knows that CSVs are typically set up to where the very first row will be like the row headers, and then under it, it will be all the values. So it takes the very first row as all the keys that I'll be formulating, and then plugs as it's iterating each one to its appropriate spot. So for example, it iterates, well, when it sees Kim, it knows that Kim should be of key of name. 31 should be of key of age. Students, key of role. That key of school ID. And then finally, key of password. Does that answer your question, Alex?
It does, thank you.
Of course. All right, any other questions? Okay, perfect. Doesn't seem like there are any questions, so let's go ahead and keep pushing forward here. So we have my load data, which we have completed. We did it for the school, but now we'll need, or excuse me, we did it for the students, but now we need to do it for the staff as well. All right. So let's dive into that. It's going to be pretty much the same exact code. So I'm going to copy it and then change a little bit of information once I get there. All right, just like before, I need to import CSV. And instead of students, well, I'll need to dive into staff. I'm going to dive into staff.csv for staff data. So let me go ahead and change that as well. Data row, that all works fine. And then instead of students from CSV, what we want is staff from CSV. Okay, so staff from CSV, we open, we're going into staff. All right, the reader grabs the staff reader, fantastic. H gets turned into an integer just like before. We create a class instance and append it. And then finally that gets returned. So all of that should work properly. Let me go ahead and come over to the school file. Or excuse me, the runner. It is the school file. Too many files. There you go. And here we're supposed to be holding a list of staff. Well, now I can call staff.load, and I think I named it load students, which I need to change to load staff. Great, now I'm gonna come over to my runner and actually print them out. So I'll say print school.staff. We get Richmond High. We see all the instances of a student class, and then we see all the instances of a staff class, all being stored within a list. All right. Any questions up to this point? Okay. If there aren't any questions, let's talk about how we could refactor this code. Well, currently staff holds this CSV file reader. And I'm going to refactor this so that I'm only writing this line of code once inside of person. Especially since it was a copy and paste, this should be something that I can manage. I can import CSV. Instead of calling it load staff, I can say load data. And I wanted to take in a path. This path will be referenced here. And we could change the convention. I can name mid list to return. Change it to list to return. And instead of calling it staff data, we can always call this CSV file. Okay, so there we go. We've changed a little bit of our naming convention. All of the other information should still remain the same. I'm not going to change anything in particular. Well, this load staff could now just return super dot load data. And I can pass in the path, which in this case I needed to go to data and grab staff.csv. Let me make sure that works properly. While I go to execute my code, that all worked great. I'm still able to create instances of staff. I didn't have to change the naming convention for load staff. I'm just going to utilize this method to call the load data method. All right. Well, I could do the same thing inside of my student. Come over to the student. And I could change this to now return super dot load data and pass in the path of data to students.csv. Let me make sure that that works as well. So now I'm able to bring in all of my students. Now I'm able to bring in all of my staff. And I only have to write the method once within the person class. All right, any questions of how we're utilizing inheritance? Well, I guess, yeah, this is still inheritance to be able to execute this information. This here, Brian.
Yeah, so can we look at the person file just real quick? I just want to see the, okay. Yeah, I just wanted to kind of look at that through the, where it was taking it from. So I guess my question is for the list to return dot append, it still says new like student. Is that, does that matter? Because it's, I mean, we're going to be using that for new student and for staff.
Yeah, we
And
can
we
definitely,
just, yeah.
yeah, we could make a new instance instead. There you go. All right, because it's a new instance of a class. All right, awesome.
Okay, and so you're just using this one person file and calling it in both the student and staff files. Okay. All right.
Yes,
Thank you.
of course. All right, any other questions? Let's hear it, Tony.
Oh, not really a question, but can you just scroll up on the person? I just have lost track of what was established there. Okay.
All right. Doesn't seem like we have any questions. Let's go ahead and keep pushing forward here. Actually, I think we probably need a break at this point. It is currently 10:02. Let's take a 5-minute break and then come back and keep pushing. So I'll see everybody back at 10:07. Thank you so much, everyone. All right, let's continue on with this README to make sure that we have accomplished everything that we need. Okay, great. So for the first assignment, we are complete. We are good to go. Let's take a look at the second assignment README now. So according to the second assignment, so we have release 0. Here's our menu. Let's think about a program. Let's create it. We get a print statement. That's not what we want. It's telling me that we're going to utilize input instead with some mode information. Here's my enrichment hot, and it's telling me to put everything within the runner. That's fine. That's where it wants the menu to live. We'll go ahead and follow that. Okay. And here we're seeing a little bit of functionality. So we're just going to start building out the functionality for this method here. Okay, this part's important. My dunder method. I think I can tackle that as well. And notice how everything that we're bringing back here, we're not exposing. Oh, we are exposing the ID, so it needs to be unique, unfortunately. But this only needs to be under the student. Okay. So let's go over to the student. The student should receive a dunder method. Here we go. Pass in self. And what this is going to return will be an F string where we're going to be placing the following information. Instead of Lisa, we should have self.name.upper because it wants all of them in uppercase letters. Here we should have self.age. And here we should have self.id, or excuse me, school ID. Great. Oh, totally forgot to grab that runner. Let's see. That's everything I should need to make things work. I can declare my menu where it is an input. There's the information that I'm taking in. Now I can make my function. Where I can say while run, I want mode to be equal to menu. That's going to call that input method. Great. Now I can go into my if statements. If mode is equal to 5, I want to turn run to false. And I can print goodbye. Why not? All right. If mode is equal to 1, I see we have a list all students. So I'm going to call my instance here, which is of school. I'm going to say list all students. Let's say else print improper input. All right. So for this list all students, I'm gonna come over to my school. I'm gonna actually create this method here. This is going to be an instance method called list all students. It's gonna take in self, and it's not going to return anything. All it's going to do is it's going to print the student for student in self dot students. All right. Let's see the runner. Let's make sure this works. And I'll address your question here shortly. So we see the runner cup populate. If I go to list all students, I can type in 1. And that doesn't seem to have worked. So school list all students. Interesting. It actually killed my menu here. Well, run.
It's because your one is a integer, not a string. That's why I was raising my hand.
Ah, got it. Thank you. But I'm also seeing that it's that shouldn't have killed my string though. Let me see. There's something else going on here. Mode is equal to menu. Oh, I see what's happening here. It should be mode. And I never even called run the school. That will do it too. Jeepers. I apologize, everyone. That was a couple little beginner mistakes. All right, so I run my code. We can see that 1 actually returns a list of all of my students. And it's able to print each one of them out. Nice. Now I'm pretty sure this dunder method should only be executed when I look at a student by student ID because I'm exposing a lot of their information. So I'm going to actually change what this list all students does. And instead, I'm going to print an F string. We're going to do student dot name. And I'll do name. And do student dot school ID to pass in the school ID. That might be a little better. Let me go ahead and pass in 5, execute it. Oh, these are all supposed to be elif statements. So if elif, there we go. All right, so now I type in 1, and there we can see Lisa, Jesse, and so on. Now I can work on taking a look at an individual student. All right, now if I want to look at an individual student, which is 2, I want to return school dot view student by ID. All right. So I can come to school, create a method, name get student by ID. It's going to pass in self. Here I'm going to grab the student input. So for now, I'll create a helper function, which will be capture ID. And all this is going to do is it's going to say valid IDs. is equal to a set. Now we'll just do it this way. Where I'm going to grab the stud school ID for stud and self.students. I'll ask to input let's do selected ID be equal to input, type in or ID of student. It's that. And then we could ask if selected ID is in valid IDs, we can return the selected ID. Else we can print this ID does not exist. All right, and then we could simply just, we could also add a print valid IDs are of self, or excuse me, valid IDs. Just that they're all in there in that string. Great. Now I just want to return the capture ID because I want them to be able to try again. Okay, this in itself seems like it's supposed to be a method. So I'm just going to go ahead and cut that out and create it as its own method. It will take in self. And I'll pass in self.capture ID. All right, so now in get a student, the first thing I need to do is say selected ID is equal to capture ID. And then finally, I can grab a student. So I can iterate through each one of them, or I could try to do something fancy and just utilize the filter function. To make it nice and readable, I'll say for student in self.students if stud.school ID is equal to selected ID, then print stud. Or actually, I could just return the student. Okay, and since this is returning the student instance in my runner, I have to print, and this should be get. There you go. So now I come down here, I'm going to go ahead and execute it. I want to view all of them. Great. Let's say I want to take a look at Dave. I'm going to go ahead and capture Dave's information. View a student by ID. Okay, it asks me for the ID of the student. Let me actually go ahead and put something that I know for sure won't exist. Okay, so it tells me this ID does not exist. Valid IDs are as follow. Okay, so now I put Kim's information. I think it was Kim. Excuse me, it was Dave's. And we can see that Dave is returned with the appropriate ID, age, and name. All right, does anyone have a question regarding that method? Let me go ahead and populate both of those methods. I have this capture ID method, this list all students method, and also have a get student by ID method. And I guess at the end of this, in case that fails, it should return nothing. All right. Any questions over anything that I've covered up to this point? Go ahead, Rick.
It's probably more of a best practices, but question. But so you're not actually in the code. You're not printing the password, even though the password's part of the CSV. And the CSV is actually readable by like Notepad and like plain text. I guess for best practices, you'd probably want to, I know this is probably beyond the scope, but install like a import bcrypt or something like that, and then encrypt and then save it to the CSV file so it's not plain text?
That's a great question. Yeah, I would probably encode and decode is what you're referencing to. So you can encode something like a password, turning it into a series of random characters, and then utilize decode to grab the original value. For
Yeah.
best
All right.
practice, yeah, you could definitely do something like that. All right. Any other questions? Okay, perfect. If there aren't any questions, let's go ahead and finish off our assignment here. Let's take a look at what option 3 is. Okay, so option 3 is add a student. That one might be a little bit harder than expected. So let's go with option 4. And what option 4 is going to do is it's going to remove a student. Well, I can say selected student is equal to get student by ID, because we know that's going to return an instance. And then afterwards, we just need to delete them, right? So I guess we could just have it in here. Say delete student. All right, let's go to the school and create this method here. It's going to take in self. Here I'll say selected student be equal to get student by ID. And actually, this might just be easier. I don't even have to grab the instance. I can just say self.capture ID. And then follow the same information. So for student, let's do for IDX in range len self.students. If self.students IDX dot school ID is equal to the selected ID, then I want to remove that student. How could I do that from there? Oh, I can do self dot students is equal to self dot students to the current IDX plus self dot students from IDX plus 1 to the very end. So that will put those two lists together. I'll print the student itself. Apologize, everyone, trying to think through this real quick. And then I'll say has been deleted. Okay, awesome. From there, I'm going to break out of my loop or just simply return none. And just in case this doesn't work, I'll return none. I think that would be the easiest way to do it. We're just simply going to fix the list so that it's missing that one index and then break out. I guess if we're doing it this way, we could always utilize pop. That would be a lot easier to do. Let's do that number.
Let's do self.students dot pop. And then pass in the index that we want to pop. Okay, let's make sure that actually works. I'm going to run my runner. Take a look at all the students available. The one that I'm going to remove will be Slater. I want to view an independent student. Here's Slater's ID. We get Slater returned. I now want to remove a student. It's asking me for an ID. I'll pass in Slater's ID. And then we get Slater has been deleted. Well, let's see what happens when I list all of my students now. And if I list all of my students now, we can see that Slater is no longer in the list. So I've successfully removed him. Definitely overthought this whole popping process, but we got to our working statement there. All right, a little bit of a key difference here. You'll notice that before I just iterated through and checked if the ID was still the same. I knew I was going to need the index in one way or another. So instead of iterating through the actual values, I iterated through the index values of the list. All right. And we don't need this part here. Good. Now the final part of our project will be where mode is equal to 3. And this is where we will construct a new student. So I'll say school, add student. All right. Let me come over to the student class, or excuse me, the school class here. And actually, I do want something within the student. Within the student, I'm going to create a class method. This here will be build student dict, which takes in CLS, and it's going to return a dictionary. The dictionary that I will be returning will have a name. I believe the next thing will be role. Let's go with that. What else do you need? Let's see. Name, age, role, school ID, and password. Oh, I'll need to figure out a way to manage the school ID. Well, because I needed to be able to manage the school ID, that means I need access to all the previous instances of a school, like of an instance of student. So I'm gonna move the location of this method back over to the school. And because I'm dealing with a instance level attribute, this will be an instance method. All right, and I'll build a method to handle the ID as well. Let's see. So we need a method for handling the ID. So I'll say generate student ID, which is going to take in self. I know they're all of integer types. So I'm just going to say max value. I'll just create sets actually. Let's do this. Let's do past IDs will be equal to student dot school ID or student in self dot students. That will give me all of the IDs. Now, because I am going to do some math to them, I'm going to typecast it to an integer. And then I'll say max ID is equal to max of past IDs. I'll make new ID equal to max ID plus 1, and then return that new ID. All right, go ahead, Tom.
Would that still work? Because I thought we had to make keep the IDs as a string because of the leading 0 on some of them.
That's a great point. Thanks so much. So I can always return it back as a string. All right. So we're returning a string. This will generate our ID. Here I can go and say, hey, I have a school ID that will utilize self dot generate. Oh, hello. Student ID. Okay, so that takes care of the school ID, the name, the role. I have name twice. I'm pretty sure it's because I was moving on to the next one. We need age, it looks like, and password. All right, so I'm gonna do password. And then finally, I need one for capture age, which takes in self, and it's meant to return an integer. I'll say potential age is equal to input. What is the student's name, or excuse me, age? Instead of overcomplicating this, let's do student age. And then I'll simply say if potential age dot is alpha, meaning that it is only alphabetical, then I will return capture age so that they can try again. And I'll print, please input an integer value. And then else, I will return integer potential age so that I can cast it. So now I can say age is equal to capture age. All right. So now I have my build student dictionary method. And I can move forward with add a student method. We'll take in self. Here I'll say student data is equal to self dot build student dict. I will then create a student. So I'll say student instance is equal to student star star student data. And I'll say self dot students dot append student instance. I'll print the student instance, and then I'll print has been added to our school. All right, let's see if that worked correctly, and then I'll open it up for questions, everybody. So I go to execute my runner. Here I get, what would you like to do? Well, I never typed it, did I? Okay, yes, I did. Add student, not add a student. Well, that's going to break it. So let me go ahead and kill it here. Naming conventions are important. All right, so now I'll go into add a student. It's asking me for my student name. My role will be a student. I guess I shouldn't even give them the ability to define their role here. This should have just been placed as student. Whoa, okay. Let's leave student. My password. And my age, where if I type anything that isn't alphanumeric, I'll get please input an integer. What if I do 20? Okay, special characters. Interesting. So it looks like special characters are considered to not necessarily be numeric. So this might throw a little bit of an issue. This is outside of the scope of the assignment, and I do want to go back and focus on getters and setters. So I'm going to go ahead and skip it. But just so everybody takes that into account. Okay, we have Francisco. My password, which is Francisco. My age, which would be 27. And now if I go to view all students, we can see Francisco has been added to the list of students. I can also grab Francisco by viewing an individual student. There's Francisco there. And I can remove Francisco by their student ID. Okay, so there's Francisco, has been deleted. And if I go to list all students, we can see that Francisco is no longer in the list of students. Finally, I can quit, and that is all the functionality for this program. All right. I did quite a bit of code in a pretty short amount of time, so I'm going to open it up for questions and then go back to the concept of getters and setters for my person class. All right. Does anyone have any questions over everything I just did? Let's hear it, Tony.
You'll be sharing these notes today, right?
Yes. Any other questions? Okay. If there aren't any, oh, go ahead, Chris.
Yeah, I was just looking at the build student dict. Doesn't matter the order, like school ID, name, role, password, so on and so forth. Is it matter if it matches to say the CSV file, like how that is ordered?
Yeah, it's a great question. It's not going to matter because we're utilizing destructuring, right? Where it's going to be looking for the keyword arguments and plug them into the correct position argument method.
Okay, thank you.
Of course. All right. Well, now that we have all this information, oh, go ahead, Dick. I mean, Rick.
Ow, called me a dick. All right, now, I guess my question is more for like the test, the pie test. Mm, is the PyTest file for like something like this going to be fairly extensive for testing all these functions?
Yes, there's going to be quite a bit of tests. I think
Okay.
each test will have its own file to make it like more readable. But I believe we're looking at more than 20 tests if you're asking in regards to this weekend.
Yeah. That's what I was asking. Yeah, we would have to look at what the test is looking for because like for some of these, I would probably code it a little bit differently. But then if the test is looking for something like the ID, you get generate ID and a generate ID function, but then I would probably code the generate student ID a little differently, but then I would have to look at the test file to figure out what it's actually looking for. So, all right. All right, that's my question. All right.
Awesome. All right, Arnold.
So the PyTest file is already given, and it's up to us to do the importing.
To do the what? I'm sorry.
The importing.
So
We
all
have-
of the importing is already going to be done for you. You won't have to worry about importing files from one another because that's not what we want this assessment to be on. We want this assessment to be on your ability to write OOP, right?
Awesome.
Not importing files.
Thank you. And so I noticed that when you were creating all these methods, you were like going back and forth and creating all these methods. So does the order matter
I'm sorry, I think you were cutting out towards the end. I was going back and forth between what?
between creating your methods and looking at your terminal menu? So does it matter where you place your class methods and your instance methods? Does it matter? Like, is it in order?
Got it. It doesn't necessarily matter. I mean, the reason why I don't want any of this code to be inside of the runner is because the runner is supposed to be clean, right? And its only function is supposed to be to execute the runtime of this menu. When it comes to the school in itself, everything is inside of the school as an instance method because I'm dealing with an instance level attribute. All right, I'm dealing with self.staff or self.students. And when it comes to order, as far as like where these functions are located, because it's OOP, it's going to read the entire class declaration and then execute wherever you're trying to execute specific or specific methods. So as far as order, it really doesn't matter. So I could change this capture ID, and you'll notice that capture ID gets used multiple times. And I could move it all the way to the bottom of my file, and it would still be able to recognize capture ID. Oh, that's not it. Let me see. Capture ID and the methods above. Does that answer your question, Arnold?
Yes, that was that. Yeah, thank you.
Awesome. All right, let's hear it, Tom.
For delete a student, if we were to use the deleter decorator, would we need to put that back into the student class, or could it stay in the school class?
The deleter decorator. Are you saying like utilize delete self dot students, or if I were to actually capture the student, like delete the actual instance? Is that what you mean?
No, I saw that there was an actual decorator, just like for setter. It would come after like an app property. And then it would be like at student dot deleter.
Yeah, so that would go within the student class,
Yeah, okay, gotcha.
of course. All right. Perfect. Doesn't seem like we have any more questions. So let me go ahead and open up the person. And let's start diving into some getters and setters for these. Well, for name, we've seen this already. I can go into property, define a name property. This is going to return a string. And I can just return self._name. Now, self._name doesn't exist yet. That's because I have not created a setter. I can say add property, name, or excuse me, this shouldn't be at property. This should be at name dot setter. That would take in a string and return none. All I need to do here, because there's no actual conditions, I guess I'll save it as a title. I'll say self.name, or excuse me, underscore name. Now this is where I'm actually creating the instance level attribute of underscore name. So I'm gonna assign it to the new name dot title to make sure that the name is always in title format. All right, moving on to age. Following somewhat of the same convention, create age. We know that age is an integer, so it would return an integer. By returning self dot underscore age, we can then grab the age setter, call age self and new age, and then deal with age, saying if age, or if not, age dot. Oh, and I guess I should specify that more than likely what I'll receive here will be an integer. If the type of new age is not equal to an integer, then I should raise an exception saying age should only be an integer. And then else, I should say self dot underscore age be equal to new age. Okay. So there's our age and our name. I'll go ahead and pause there before diving into role and password. Does anyone have any questions between our name and age getters and setters? Let's hear AJ.
Okay, so it's probably a dumb question, but when I was like coding along at times, I noticed that the at symbol, when I forget it, the property still was glowing. Same thing with like some of the other terms. So is the at just a best practice, or does it actually have a function for it?
I'm saying if I do this number,
Yeah, like it still glows. It looks like it still should work without the at symbol, but I'm not sure if the at is doing something else or if it's just a best practice.
yeah, that's a great question. So that's actually going to throw an error if you try to execute it. The at is marking that the following line after the at is going to be a decorator or act as a decorator, meaning that it's going to take in the function as a function. So the moment we utilize this at property, what it does behind the scenes is essentially it takes in hey, well, we're gonna need a wrapper named age, or we'll just call it a property. This property takes in a function. And what this does is it dives into self. And then it returns the function activation. All right, so it kind of messes everything in between. But by adding this at symbol, that's what tells, hey, this here is the function that's supposed to be passed in. And then later on, triggered in the return statement. Without adding this decorator portion, the decorator won't actually behave the way you want it to. So you need that at symbol. Does that answer your question, AJ?
It does, thank you.
All right. Awesome. So there's our name and our age. Let's dive into role and password, which are going to be our last two. So again, we have our at property. This is going to be for role, taken self, and this is going to return a string. It just needs to return self.role. And then finally, we have our role.setter, where we call upon role, self, new role. We can ask if role or excuse me, if the new role let me specify this is supposed to be a string and return nothing. So if the new role not in student or staff, because those are the only two roles that should be accepted, then I need to raise an exception saying role should be either student or staff. Otherwise, I can assign self dot underscore role to be equal to new role. And I was supposed to be returning self dot underscore role. I apologize, everyone. So there's my role getter and setter. I'm making sure that the only input that I'm accepting is of student or staff. And I could make it a little bit more dynamic. I could have it to where what's accepted could be all lowercase. And then when it's set to its actual value, I place it in as in title case. All right, let me make sure everything works up to this point because I do want to make sure that my data is able to be loaded. Okay, so I'm seeing some errors already populate. The error is coming from role where it's saying, hey, the role should either be staff. And I can see that this is being raised in person.py line 7. And it's happening line 6 inside of staff. So let me take a look at staff. Line 6, where I'm trying to initialize a role. Okay. And that's happening because I am utilizing my read data back in the person. Okay. And it is only happening with my staff. Great. So there's my staff. The information is coming from the staff CSV and it's throwing an error. So let me take a look at staff role. So it looks like role isn't just as simple as I thought it would be. So we have teacher, janitor, and principal. So I need to add that in to my setter that I created for person. Okay, so principal, janitor, and teacher. And now it works properly. All right, and then my final getter and setter, which will be password. And we could throw some sort of password requirements if we wanted to. I'm going to keep it nice and simple. Just going to say at property. Here we have our password, which is going to take in self, simply return a string. Here we have a separate property. Or excuse me. Here we'll make our setter. Which is going to take in self and new password. I know it's going to return none and that this should be of a string type. And all it's going to do is going to say self dot underscore password be equal to new password. And I can make it so that we don't accept empty strings. I don't think anybody has an empty password. Let me make sure. Okay, everybody does have a password in the staff CSV. Let me make sure students, everybody has a password. Great. I want to make sure that a password is in fact passed in. So I'll say if not new password, then raise exception. Password cannot be empty. All right, there's all of our getters and setters. Let me go ahead and execute this. Everything has worked. I pass in number 1. I can see all of the students. I pass in, let me go ahead and grab a valid ID for Doug. I go into line 2. If I type in gibberish, it's fine. It gives me another option. Okay, I can see Doug that's being returned. I want to add a student. In this case, it will be myself. And just to make sure that my getters and setters are working properly, I'll pass it in under with a lowercase letter. My student password. Here, I'll go ahead and set it to Francisco. And then my age. I know that if I put gibberish, it's going to ask me for my age again. So I'll go ahead and put 12. If I want to view all students, Francisco has been added. Here's my new ID. I want to remove a student. I'm going to pass in my ID. And we can see that Francisco has been deleted. If I go to list all students, Francisco is no longer there. And then finally, I can quit my project. So utilizing inheritance, let me do a quick overview of everything. Starting off with the person class. The person class utilizes CSV to be able to read from CSV files. It also has some common attributes that are shared between staff and students. Name, age, role, and password, all of which have their own getters and setters. Finally, we have one class method that is meant to read from a CSV file and accept a path as an argument. It opens the CSV file, turns the entire all of the CSV rows into a dictionary. So this actually returns a list of dictionaries. We then iterate through each dictionary entry, typecast that age into an integer, and create an instance of the class. We then append it to the list and return the list as the value. Now, in the staff class, we utilize super to bring in person, or excuse me, we utilize inheritance to bring in the person and inherit. We then utilize the super method to pass in all of our instance level attributes to the proper staff, because we have a unique value for employee ID. We then load all of the staff, which is a class level method that leverages the load data method that we created inside a person. And we pass in the proper path to find the staff CSV. In the student, it looks pretty similar. We are inheriting from person. We can see that we utilize the super method to be able to set all of our instance level attributes to a person. And in our load students, we're utilizing super again to access that load data method and pass in the path to our student CSV. At the school level, when we initialize our school, we take in a name as a parameter for string that gets set to the name as self.name. Here, we can see that the staff is actually a list of staff, and we're utilizing that class method of load staff. Same with students, we're utilizing the class method of load students, both of which would return a list of students. We then go through the process of creating some methods to be able to run our menu, such as list all students, where we utilize list comprehension to be able to print each independent student in this format. We then go into get student by ID, where we capture a student's ID through a separate method, ensuring that the ID is valid. Once the ID is valid, we return said ID, which allows us to actually grab a student instance. We have delete a student. We're not actually deleting the student itself, but rather deleting it from our list by utilizing pop. So pop removes a student from the list. We then dive into the method for being able to create a student. Now, in order to be able to add a student, we need to build a dictionary. This will give us all of our student data. That dictionary leverages a method named generate student ID, which comes up above and returns a string. We have name, where we capture the student's name, role, which we dictate ourselves to be a student, password, where we're asking for the password of a student, and age, where we leverage another method, ensuring that the age that we are accepting is numeric. And I guess that would be a way to fix this, is just to check if it's numeric rather than checking if it's alpha. All right. From there, once that dictionary gets returned, we build a student instance, add that student instance into our list of students, and then we give a success message saying that the student has been added to our list of students. Within the runner, we initialize the school of Richmond High, and then we build our menu that gets repeated over and over again through a while loop until the user willingly types in 5, at which point our while loop will stop and we state goodbye. If they type in 1, it will list all the students. 2, we'll get a student by ID. 3, we'll add a student into a list of students. And 4, we'll delete a student. At this point, does anyone have any questions over the material that I've covered today? Let's hear it, Tony.
Yeah, so it's not really a question about what you went over, but more or less on your, I'm trying to remember, I think it was person, when you did the role setter, having to type in each of the roles there, is there a way to just access the dictionary, like the data, to determine if the role's in the data? Like, for example, I worked in medical billing, so if I had, payers, right, like insurance carriers, there's sometimes on our CSV documents 150 different payers. I wouldn't be able to list all that out. How would I go about, or is there a way to, I don't expect you to go way too off scope, but is there a way to just pull that data from the CSV as opposed to typing each one individually?
You can, yes, you could create a separate method that would read the CSV file and then only pull the column of role out of it, not necessarily in the students, sorry, in the staff, that would only pull the column of row, and then have that be your list, or excuse me, your set, because you don't want repeated values. You could have that be your set. Once that gets turned into its set, it would essentially return an iterable data structure with unique values inside of it. That way it's not searching something massive if there's any repetitive values.
Got it. Okay, thank you.
Of course. Any other questions? Let's hear it, Ryan.
Just out of curiosity, when you go through all this and actually add a student, does that update the CSV file?
It does not.
Oh, okay. All right, thanks.
Of course. All right, everyone. Doesn't seem like there are any other questions. This, of course, will be shared, and I'll make sure to download the videos and share them in YouTube as well. Let me go ahead and stop our recording here.